G'day everyone and welcome back to my channel. So as you can see, I've put the other side in it now, the LM301s. I put the polystyrene compensation capacitors back in. I believe the 268 mic were on the current side and all the 100 and, sorry not mic, picofarad, and all the 120 picofarad ones were on all the other op amps. I could be wrong. If it seems most stable at this butt, because when I had 82s and 150s from my parts store in there, I had the bigger value on the opposite op amp and it wasn't perfectly stable. So I think I actually have got it right, but I know in the future. Anyway, just wanted to show you this. I've calibrated it. I wasn't going to do all that on video again, sit here and twiddle pots and adjust references and all that bull crap in front of you. So you guys have seen it plenty of times. It's working, so I'll just take everything off for a sec. I'm literally about to put the cover back on this and put it on my bench. I'm finished. For now, like I said, in the future we'll see if we can do some upgrades to it possibly, but right, so voltage. Oh, the only other thing I'm going to do is I'm going to take this current pot out and solder the bottom of it on. So see how if I hold it down, the voltage drops. Whereas this side, if you turn the current down, it just drops. Because I fixed that pot. So I want to fix that pot. That's just a pot. But anyways, oh my God, did I really do that? So as you can see, the voltage goes up to 30. Meter and the thing are calibrated. Incidentally, if you put a load on this, it doesn't drop a millivolt. The regulation is beautiful, so that is accurate as. Also, the meter's looking at the output anyway, so yeah, it's nice and accurate. The slave channel. Wait, is that still in view? Yeah. Slave channel. 30. Alright, I'll turn these voltages down. We'll go to amps. Put my meter on current mode and we'll go to amps. Like I said, this side good pot winds down completely to 0. It goes just over, but if I set it at an amp, it's calibrated to 1 amp. That's all it goes over. Not much. 1 amp, bang on. Right? That one goes up to 1007. I guess I could bump that panel meter up just a smidge. That's this one. Wait, why is that not having an effect? Don't tell me I'm turning the wrong pot. Oh man, I think I've just thrown the voltage calibration out. One moment please, sorry. Yeah, that was for the voltage. minutes. Hold on a sec. Something doesn't seem right here. 1 amp. That was the amp one. I just hadn't turned it enough times. Alright, so which way are we going to go just over? Not that way. There you go, you get to see a little bit more calibration. Yeah, there's good. If I put it to exactly 1 amp, oh, just a little bit more. Oh, I'm going the wrong way again. Oopsie. I'm happy with that. Maybe just a smidge more that way. Oh, not too much. Eh? Yeah. Oh no, it is down a little bit. Sorry guys. I keep turning the pot the wrong way. I keep forgetting which way's up and which way's down. That is bang on. Yep. That's 1 amp. 1 amp. Beautiful. Alright, so the meters are calibrated now too. By the way, it holds it like great. The constant current and the constant voltage regulation in this is just wonderful from what I've seen so far. So, what's wrong, you may ask? One thing. But I am not surprised because I have not done one thing yet. Let's have a look at our reference. Okay, looking good. But let's turn the current limit on. Yikes. As I suspected, the capacitive load would change as op amps do different things and the circuit does different things, and the TL431 would have unstable regions. So I'm just going to slap probably a little, you know what, I used a good MKT. I'll stick another I'll put MKTs on the back of them all, and 4.7 mic electrodes on the front of them. Actually, I ended up doing a test with 47 microfarad caps on them, and it didn't actually it didn't cause any overshoot. So I think what I'll do is I'll just hook up a scope probe quickly, so just so that we can hold a capacitor on it and see what effect it has live before I go off and do it. I'll just pause the video whilst I go grab some caps because I packed everything up. Alright. So with a 47 mic, yeah. Let me get a 4.7. I should have grabbed that whilst I was here, shouldn't I? I don't think sometimes. I would much rather just a 4.7 and a 1 on it because it's going to allow it to charge up a lot faster. I thought I just put a capacitor in the wrong drawer. Sorry. It will allow the voltage across the cap to charge a lot quicker, and the reference will come up the voltage quicker. Let's see what a 10 mic does. That was a 4.7. I've got some 10s that are at 63 volts, so they're going to have fairly low ESR on them too, because they're 63 volt caps. Let's see what a low ESR, essentially 10 mic, does. Let's compare that to the 47. Well, that is going to have an even lower ESR. This is also at 63 volts. Yeah. Seems like I want the 47 and the MKT is back in there. That's alright. Well, I'm going to go off and do that. Put the cover on it. Because that's literally the only thing I'm concerned about. Oh, and if you're wondering too, auto tracking. I guess you want to see volts for that. This... Oh, yeah, current zone. This right side does still go up a little bit too high. So like if you turn this up to 30, so if you put in auto tracking and then turn it up to 30, see that one's just ever so slightly above that one. But if you turn it using, because that becomes ratio adjusting auto track. If you set it right, it tracks perfectly. So there's nothing wrong with it. I'm not worried. And when I pull the boards out one last time, I'm going to double check all the reference voltages, because chances are reference voltages are off and stuff like that too, you know. But I'll double check everything. Actually, wait, what am I saying? I set the 5.1s myself, and I just did the 3.6s again like 10 minutes ago. So no, I'm not going to double check the references, because I've done them in the last 2 days. The 5.1s yesterday and the 3.6s again today. So I know they're right bang on. I guess I'll just leave it. It's fine. I'm happy with it. I'm more than happy. The thing that bothers me the most is that it works. It's calibrated. Oh, and of course, you know, number one important thing, obviously I'm not going to do this test loaded until I put the caps across the references and fix the pot, put the cover on it and that, but that's with a huge ass ground loop, you know? So I'd say it's pretty quiet. Let me just get rid of that. This is probably still going to be just as bad. Because I actually honestly don't remember it looking that noisy before. I'm at 20 millivolts of division, so even that looks small. It's actually not too small. Oh yeah, no, that was just a ground loop. So yeah, this thing's quite, that's already 700 and something microvolts. I'd say this thing's down around 200 microvolts RMS, maybe 900 microvolts peak to peak, if I had to have a guess. I put that common mode network back in it. It turns out those wires were star grounded, so I ended up using the same wire. If there's a few microvolts of common mode noise on there because I used the same wire, so be it, it's nothing. Anyway, I'm always happy when my power supplies are down in the microvolts region for everything, so that's where this is going. I'll fix this pot. I'll put the 47 mic caps in with the... Well, let's have a look at that too. Let's just quickly have a look and see. Actually, I'm going to need my ground clip. With the 47 mic cap in there. Does an MKT still... What's going on here? There it is. Does an MKT still help? Because I was noticing a high frequency component and a low frequency component to it before, so that's why I was using both, for anyone that was wondering. Plus, you know, if TL431 breaks out into oscillation, it's usually going to be high frequency. So let's quench this with the 47. And let's see if we can knock that out with no difference. Alright, 47 microfarad caps are going, and then the pot's getting fixed and the cover's going on it. So there you go, guys. I'm not gonna sign off here. What I'll do is I'll do said work that I'm gonna do, just in case something goes ape shit wrong and turns sour and it comes and haunts me, and I come back and I'm like, you're not gonna believe this, but you know, I'll go and put these parts in it, and we'll double verify that the outputs are nice and quiet and everything's working still, blah blah blah, you know. And if it is, well, job done for now. I'll be very happy. So I'll be back in a second for you guys. Alright, I just realised that wasn't even grounded. That's hilarious. Wait, that means I'm going to have to do that test again. No. Hey, at least I noticed. The worst thing is when you don't realise that you've taken a test measurement incorrectly, and then you go and base your work off of that measurement, and then you find out later on that your measurement was wrong, and then therefore all your work was a waste of time. That would not be good. So let's try that again. We'll quench this with the 47 mic, and then we'll see if this high frequency looking stuff disappears with the MKT1 mic. No difference. Okay, so I'm just going to put 47 mics across each reference, fix that pot, and I'll be back in a sec. Okay, well, I'm not fixing that pot like I just said I was, because I can't. How do I explain this? The pot on the other side is actually the one that I fixed. This is the pot that I fixed. So either there is something funny with the wiper and the coil alignment, or I don't know. I'll double check the reference voltages on the constant current circuit just in case this one is a little bit low or high or whatever. Yeah, low. I can't think, but you know what I'm saying. I'll double check. Otherwise, look, I've ordered new pots anyway, so it doesn't really bother me. You know, when the new pots arrive, I'll put them in. I've already put two 10k ones in here that are new for the voltage. I've just got to change these two 500 ohm ones. So when my new pots arrive, I'll do that. I've made up a nice little probe here so we can get some good measurements without any interference. It fits perfectly right there, and we can do this up, leaving that ground loop, whatever you want to call it. So I'm now going to fit these 447 mic caps. So these boards, by the way, here's the boards from the top. You've already seen the references and the resistors and everything I've done, the snubbers, the caps, the big power resistors. There's the LM301s back in there. On the back I've just got the polystyrene capacitors across the compensation legs, and I've left my power wire and output wire because, like I said, I might be changing op amps in the future. If not, who cares, it's good enough. It works. I already ripped the traces off. Right, so I'm literally going to go install these caps now and come back and we'll scope it out under load and whatnot, and we can finally start on a new project. Because the other board's already got Where are they? Oh, there's 2 holes I drilled, plus there's 2 other holes. I can mount a cap there already, but there was no way to mount a cap on the top of this board, so I just drilled a couple of holes there, and I'm just going to fold the leads over to those 2 points. So I'll get that done now, I'll be back in a sec. Alright, the 47 mics are fitted. I recalibrated the references because I bumped them. Leads just go through those holes and fold around to the pins, the reference pins. It's not messy at all, really. Actually looks quite neat now. This board did the same thing because the caps won't stand up straight. I've got 2 different sizes of 47 and 63 volt. This is the smaller size. The other one was even fatter and longer. And I still had to fold that over, otherwise it wouldn't have cleared this length here. It's longer than that. So there it is. Let's put these boards back in supply. And hopefully, for some time until parts arrive, and well, not just the pots, but if I'm going to upgrade op amps, I'll probably end up having to order special op amps for the job, because there's a good chance I might not have anything compatible in here from what we've seen so far. I still haven't obviously looked through everything and looked at data sheets and spent time looking at it, but it also depends. I wouldn't mind trying to get a schematic for this, so I called those people today that this company is now. See if they get back to me. If we get a schematic, we'll be doing more with it, I guess, than what we'll be doing if I don't get a schematic. But for now, I'm just happy it's finally up and running after all that bloody time. And I was not expecting that. I'm also happy that there's nothing wrong with the wiring in it, because I was always suspicious that someone did something wrong with the wiring, but I was also saying the whole time that oscillation can present itself as a lot of weird symptoms. So I always thought it was one of the two, one or the other. Can't say both things at once, and that was oscillation. So, great, look at that. I'm happy with that. I did say that little bit of overshoot. That's what I was talking about by putting 47 mic on there, but I can live with it. It's not like I'm going to be turning on and off at the power switch to turn loads on and off. Like, that's just stupid. If I'm going to want to turn loads on and off of this, I'll be unplugging it. Or I might in the future add on-off switches for the outputs. So that's not a problem for someone like me. Just make sure this is still working. Turn the current up. Yep, this is still working. Turn the current up. You beauty. Auto tracking. Can't ask for more than that. Alright, let's do one more test and let's test the current just in case something's gone and changed by adding capacitors to references. Nah, looks perfect. Yep. You can literally set 1 milliamp on here, so. And 1 millivolt. It's great. It's great for old technology. Multi-turn pots. When you've only got an amp and 30 volts over a panel motor, you can get pretty good accuracy on it. Think about it. You go up to 5 amps and you're losing an order of magnitude of accuracy there. What am I doing? Amps on this side. Rightio. I'm happy. And you know something? I could put a trim pot on that because you know on that side if you trim the current pot down, the voltage goes down ever so slightly. I could do that and readjust it, but I really can't be bothered. It's perfect as it is. Doesn't need any extra parts in it. It's already got 4 calibratable references, four points of calibration for the meters, and then 2 points of calibration for each voltage pot, plus the user access on the front of it. I don't need to add any more to it. That's plenty. Especially considering this thing's from the 70s. It's bloody wonderful for something from the 70s. That's why I wasn't going to give up on it. That's why I bought it. Like I said, I like stuff like this because you can always fix it. It'll last a lifetime, and it works great. Well, how can you complain? Let's have a look on the scope now, shall we? So I've got a custom lead made up ready here. I like the look of that already. Yeah. Holy shit, that's exactly the same as the Sublime building. 660 microvolts peak to peak, RMS 60 microvolts, 58, 55. That's the same ballpark my one is in that I've designed myself. That's hilarious. That's unloaded, but just in case anyone thinks I'm lying, you can see the figures that I got mine down to at the bottom. 480 microvolts peak to peak, 50 microvolts RMS. Yeah. What a coincidence, eh? They just don't make stuff like this anymore. Nowadays, it's normal to have a couple of millivolts. Like, what the fuck? A couple of millivolts? You stick a speaker in series with a capacitor on the output and you can hear it going bzzz. It's a DC power supply. Go figure. Anyway, let's give it a load. I'm not going to do it with the load bank because the load bank's like pulse width modulated MOSFETs and it's all choppy, it's not filtered, and it'll make the waveform look terrible and it's not actually the power supply, it's actually just a load bank. So what I've got here is I've got some nice 10 watt 100 ohm resistors all piled up. What have we got here? 50 ohms, 25 ohms, I think about 12.5 ohms there. So let's see when we load it down, put the voltage up a little bit, give it 6 volts. Let's see when we load it down how much extra noise and ripple we get. Right, so with a load across it, a couple extra microvolts, let's start cranking the current up. 400 milliamps. We're still exactly the same basically. Oh, the peak to peak's gone up a bit. We're now at 120 microvolts RMS and 1.12 millivolts peak to peak. Yeah, it's pretty. Oh, no, some. Yeah. enough right now. Said it's gone on for long enough. I've got enough other things to do, so I think I'm going to leave off here, and I'm going to work out what to do next for a video. I think I'm going to start on this Yamaha mixer now, because I've now got 2 dual tracking supplies. One also goes in parallel mode. They obviously all go in independent mode. So I've got one that does dual tracking and independent, one that does dual tracking, parallel and independent, and a single supply. I mean, technically you could wire them all together in parallel, but you know what I mean. So I've got enough rails now finally to satisfy myself for now. Plus there's a supply I'm building, but I'm not going to put that back on the bench until I finish that mixer, because I'm just going to end up with shit everywhere in here, and it's already like that at the moment. So thanks for watching. Thanks for everyone that's stayed through this series, because I know it did take a bloody long time. Honestly, I don't know what to say. Like, there's certain things that I regret doing, but at the same time, how was I to know without being able to get schematics? And honestly, with the way the iPamp's behaved in there, I don't think anyone would have guessed that was going to happen, because this thing's got pretty low gain transistors and it's got a pretty tight loop response, you know, so your guess is as good as mine, but it's definitely working well now. So I'm going to screw all the boards in and put the cover on it, and I think what I'm going to do, because I've got this one sitting here next to my load bank, and then there's a 3D printer, a little shit scope, and like microscope, and my computer. I think I'm going to put it in there and put that power supply and my function generator on top of it. But we'll work it out. Anyway, thanks for watching everyone, and I'll see you in the next one. Bye for now.